Welcome to the seventh video on moles, okay, the seventh video on this session, and we're going to be speaking about back titrations. So, what is a back titration? A back titration is a titration done in reverse. Instead of titrating the original sample, a known excess of a standard reagent is added to the solution, and the excess is titrated. So pretty much, you are not doing one titration, but rather you are doing two. So, there are two types of back titrations. Okay, the first type is when you have A plus B to give C plus D, and then C can then react in the second reaction. An example is the preparation of iodine here. Okay, the preparation of iodine here, where iodine is first prepared from the persulfate ion, and then the iodine prepared is reacted with thiosulfate, okay, and you can titrate against that. Now, there are a number of reasons why you might want to do this, okay, but we'll leave that for another time. But here, there is one thing that is very important to note, okay? The amount of C in both reactions is the same. Okay, the amount of C in both reactions is the same. On the other hand, in type 2, we have excess of one substance, and this excess is then reacted. So the amount of B is not the same in the two reactions. Okay? And that is something that is very important to note. So in one, you are reacting what you're producing, and therefore they must be the same. In the second one, it is completely different. They are unrelated. Okay? And we're going to see some examples, one example of each, to see exactly what is happening. So let's see a word example. A student was asked to determine the mass in grams of calcium carbonate present in a 0.125 gram sample of chalk. The student placed the chalk sample into 50 milliliters conical flask and added 50 milliliters of 0.2 molar HCl using a pipette. The excess HCl was then titrated with 0.25 molar NaOH. The average NaOH titer value was 32.12 milliliters. Calculate the mass of calcium carbonate in grams present in the chalk sample. So the first thing you need to do is write the equations. Okay, so let's start by writing and balancing the equations. Remember, an unbalanced equation will make life very difficult for you later on. So there was the calcium carbonate with HCl and hydrochloric acid with NaOH. Now then, once you do this, you write the information that you've got, okay? And you have 32.12 milliliters NaOH, and it is 0.25 molar. And that is the only information that you have, because HCl must have been in excess, so we can write total HCl is going to be 50 milliliters, 0.2 moles per decimeter cubed, okay? And calcium carbonate, it's an impure sample because that is what you need to find. So in order to then establish what you're gonna need, you can actually start backwards. So you need to find the mass of calcium carbonate. To find the mass of calcium carbonate, you must find the moles of calcium carbonate, and that's gonna be that one. But to find the moles of calcium carbonate, you must find the moles of HCl. And HCl, we're gonna write them as A and B. So moles HCl A. And here we need reacted. Okay? So to find the moles of HCl A, we must also find total moles of HCl. And we must also find excess HCl B. So that would be this one down here. Okay, and we can find excess HCl by finding moles of NaOH. So it's working backwards. So it would be A, B, C, D, E, and F is our answer here. Okay, so once you make the plan, you just move on to try it out. Remember, not all plans will work. Sometimes you might need to revisit what you're doing. It's okay. You're practicing, you have enough time. Okay, so let's see. A was finding moles of NaOH. And I would personally write the title down and then I would start working. So it's 0.25 moles in 1000 milliliters. How many in 32.12 milliliters? And it will be equal to 0.00803 moles. From here on, we can find, okay, so from here on, we can find the ratio for B, where we have HCl to NaOH, okay, and the ratio is 1:1, therefore, this will be the same number, and it will be 0.00803 moles of HCl. We can then go on, okay, and work out how much was the total HCl in solution that was added. So total HCl added, and this was 0.2 moles in 1000 milliliters. How many in 50 milliliters? 50 divided by 1000 times 0.2, which is equal to 0.01 moles. Then we can go to D. Okay, and D is going to be HCl A, which is equal to total minus excess. So this will be 0.01 minus 0.00803, which would be equal to 0.00197 moles. Okay, after this, we can find E, where we're gonna have the ratio, so moles CaCO3. So CaCO3 to HCl is 1:2. So how much will it be if you have 0.00197 moles? And this will be 0.000985 moles. Okay, it will be exactly half. Okay, and from here on, we have found the number of moles, so we can find the mass of calcium carbonate. And here we can say that 1 mole calcium carbonate is equal to 40 plus 12 plus 16 times 3, which is equal to 100 grams. 1 mole equals 100 grams. Therefore, 0.0009855 moles equals how much? And that would be 0.0009855 times 100, which is equal to 0.09855 grams of CaCO3. And we can see that that number is close to this number over here. It's not 100%, but you'd expect it to be lower because chalk is a mixture. It's not just calcium carbonate, but it's close enough. Okay, so you should be comfortable when you see an answer like that, that your answer is correct. The second question is this. A sample containing 10 grams of an unknown salt was dissolved to give to 50 centimeters cubed of solution. On heating 25 centimeters cubed of the solution with an excess of potassium iodide, iodine was formed equivalent to 25 centimeters cubed of 0.1 molar sodium thiosulfate solution. And you have been given the equations. What mass of copper was present in the 10-gram sample? So again, I know he's giving you the equations, but you don't do any harm by writing the equations down, because at this point, you would need to visualize what you're being asked of. Okay, what's being asked out of you. So something like this is gonna help you out immensely. Something like this is gonna help you out immensely, okay? So you write down the information, and the only useful information that you have here, we're gonna do the planning, but the only valid information that you can use for this titration is going to be 25 centimeters cubed of S2O32 minus, and the concentration 0.1 molar. But once you get to this position, then you can start thinking about what you need to find. And you are asked to find mass of Cu in 10-gram sample. And that would be into 50 centimeters cubed. But you know that it was diluted. So you might find moles of Cu in 10-gram sample, and also moles of Cu in 25 centimeters cubed. Okay, so there was a dilution and you only used 25 centimeters cubed of the solution. But to find the moles of Cu, we must be using that iodine. So we must find the iodine. So moles of I2. But it's important to note that they're gonna be the same. And of course, the moles of iodine, you can find them by finding the moles of thiosulfate. So here you will be A, B, but B's are the same, C, and then D and E. So let's actually try and work it out. So A is moles of S2O32 minus, and this will be 0.1 moles in 1000 centimeter cubed. How many moles in 25 centimeters cubed? And this will be 25 over 1000 times 0.1, which is equal to 0.0025 moles. Then B is going to be the ratio. So moles I2. So S2O32 minus 2 I2, it's 1, it's 2, apologies. It's 1 is to 2, so 2 thiosulfate to 1 iodine. It's going to be 0.0025 is to how much? And it would be 0.00125 moles I2. Okay, but we know that the two reactions, the iodine is the same. So Because the iodine is going to be the same, then we can go to C. And in C, okay, we can find the moles of copper. And Cu to plus 2I2, the ratio will be 2:1. So how many to 0.00125? And this would be 0.0025 moles. And from here on, we can just find the moles in the original sample. Okay, moles in 250 centimeters cubed. So this would be 0.0025 moles in 25 centimeters cubed. How much in 250 centimeters cubed? And it will be 25 over 25 times 0.0025, which is going to be equal to 0.025 moles. Okay, I written it underneath it because I need space to finish the last bit of this question, E, and this would be 1 mole Cu equals 63.5 grams, 0.025 moles equals how much? And this would be 0.025 times 63.5 grams, which is equal to 1.5875 grams. And that is your final answer. Okay, and it's smaller than 10 grams. It's important. Now, the salt here in question, I know it was a mixed salt, okay? This is a hydrated mixed salt, okay? And it was a hydrated alum salt. So the percentage and the mass seems to be correct, okay? But in your case, you wouldn't have known that. Just try it out and be comfortable with the steps you've taken. Okay, but as you can see, even in a back titration, we're not using any new chemistry. Even in the back titration, we are simply, or you are simply doing the same reactions, the same equations, the same calculations that you were using in the beginning. That's why it's important to build confidence using some simple modes. Okay, thank you. If you have, please work the questions in the description. Okay, and if you have any problems, do not hesitate to ask me. I'll see you for the last session, which will be on redox reactions. Thank you.